Gonna broadcast.
Okay.
Just gonna jump right back in.
All right. Welcome back. Hope you can hear us now. Hope you can see us now. And we're going to continue talking about geology, the study of the Earth and the parts of the Earth and how they were formed. And so we're going to jump right in to a slide.
Into here. All right.
Excellent.
So we talked about this one.
Okay, we'll talk about this one again. So
Next
here's
one.
Pangea. This is the one I wanted to
All
show.
right.
So the
Looks
Earth,
like a gumball.
it's kind of chewy. Talk about a jawbreaker.
Yeah.
Okay.
Okay, everyone's saying we're fixed. Yay!
Yay!
Thank you guys. Thank you for your patience as we sorted that out. Here we go.
Okay, so the Earth is made up of these different layers. So this is geology, how these things happen, how the Earth forms the way it did. And you can see the crust is a very outside layer. It's only a few miles deep, and it's all around. It includes land and water. And so that's the crust. That's what these different continents seem to be floating on. The next layer is called the mantle. There's the upper mantle and the lower mantle. For those old timers, there's no Mickey mantle. That's a different story. But there's the upper and lower mantle. They go down about 2,000 miles, more or less, from the surface. Now, the Earth is only about a little less than 4,000 miles in the radius. The diameter is about 7,800. So anyway, about halfway down is the mantle part, and
Shanna was a little bit. Mickey Mantle is an actor,
baseball player.
baseball player.
In the 60s.
Shanna, I'm with you. Don't worry.
The 1960s.
Yeah.
Number 7 for the Yankees. Okay. Anyway, the rocks that make up the upper layer are cool and can break easily, and the rocks that make up the lower mantle are soft and like putty or molding clay, because we're getting lower and deeper into the Earth, and there's a lot of heat building up that can make these things softer.
Mm-hmm.
And then we have the core. There's the inner core and the outer core, and the rocks in the outer core are so hot that they melt. So all of this pressure is melting the rock. And so when you have volcanoes and that sort of thing, it's the melted rock from the core that comes up through cracks and whatever, and cracks in the Earth and cracks in the mantle, and could come up to the surface. And we're going to talk about how that happens in just a minute. Okay, now the center is the inner core, and the inner core is what gives us the magnetic effect that we have. Magnetic, North Pole, South Pole, magnets point to the North Pole, and so that's because of
It's what makes my compass work.
I thought I said that. Anyway, that's what the inner core does, because the inner core is made of iron and nickel, and iron and nickel are both metals that are magnetic. So that's what the solid inner core does, because it's so much pressure that it's even more pressure than the outer core. The inner core is solid. Kind of interesting how it does that.
It is, yeah. Squeezed so much. There's so much pressure, so much, yeah.
Anyway, plate tectonics is what it's called, is the theory scientists developed to explain how these different parts or plates on the Earth move around, and how different parts, continents and whatever, have moved over gazillions of years. So we're going to show you the next slide, which will give you an idea of some of the plates. So these are the different plates. There are big plates and little plates, just like in my cupboard. And some of the big plates where, the North American plate and the South American plate. And there's the Pacific plate over there just to the very left. And the Pacific plate starts, right along the coast, the west coast of the US, and it goes right on the other side to to the east coast of Asia and Japan. And so this is called the Ring of Fire because these plates can sometimes slip. We'll be talking about that in a little bit, and cause earthquakes and all of that good stuff. So here are some of the different plates that we have. And this is a current theory as to why our world looks like that, how the different continents move around. And anyway, we are right.
I think it's fascinating. Just looking at this, and then you try to figure out like where are the mountain ranges and where do the continents start and end, and you can start to piece things together.
Well, what happens is sometimes one plate will be going this way and another plate will be going that way, and they're sort of rubbing up, pushing up against one another, and then eventually one goes underneath. And when that happens, it could be an earthquake, or let's take a look at the next slide. If you'll notice on this slide, there's the Juan de Fuca plate right off the west coast. That's Washington, Oregon, California, and Canada. And let's take a look at our next. Nope, that's not the one I wanted. That's the one.
There we go.
So there's the Juan de Fuca plate, and it's going under the North American plate. And you can see some of the land getting pushed up there, forming the coastal range, a series of mountains along the coast. And sometimes there's a little leakage there from the inner core, or I'm sorry, the outer core, and that's where you can get volcanoes and you get this hot lava coming up. There's the American plate going this way, and these two plates are sort of meeting, and one of them has to go under, and that's what's happening here. Anyway, that's the plate. They say that there's earthquakes coming, and this is what forms earthquakes. And it's when it goes underneath like that, that's called subduction. Sub means under, of course, like a submarine. And its subduction is when one goes under another. And that subduction itself is enough to heat up rocks and change them into liquid rocks, which we call magma, which can form volcanic eruptions. What was the last slide that we skipped over?
That was this one here.
So you can see here how sometimes we get these volcanoes because there's leaking from the outer core and it comes up through cracks, or sometimes you could see we get these volcanoes because there's subduction going on where one goes under the other and that melts some rock. Tremendous amount of pressure. But also here, there's sometimes you have two plates and they're going in opposite directions. And when they go in opposite directions, now that makes it very thin on top. It leaves a little space. And so some of the inside warmer rocks will come up to take up that space. Between the North America and Europe, we have this mid-Atlantic ridge, it's called. And that's what causes this ridge, this bunch of mountains under the ocean, because you have these two plates moving apart. And so you have some hot magma coming up, getting cooled off by the water, and bingo bango, you have these, a spreading center, they call it here. And so that's what causes these underwater features. Anything else? Oh, and you can see there's this motion going on with just like if you have a lava lamp. I don't know, do they have lava lamps? They have lava lamps these days. So you have lava lamps.
I sure did growing up. Yeah.
I did growing up. And so you have the heat coming up and then it's cooling down and it comes back down, then it gets hot again. So that's what's happening here on our Earth. You have all of these different motions of the rocks as they get hotter, they come up, they get cooler, they come back down. And that's what convection is. Okay.
There we go. And
so
then
there's a Juan de Fuca.
Yep, there we go. I wanted to add one thing to this slide.
Yes.
For those of you that are familiar with the geography of Oregon, and you've got after you drive a couple of hours inland from the coast, you've got all those mountains. You've got Mount Hood and Mount Bachelor and Mount Jefferson and Mount Adams. And there's all these, Mount St. Helens. You've got all these volcanoes there. This is how those volcanoes are formed. That's what's going on. There is all that stuff that formed those volcanoes was once under the Pacific Ocean, and then it traveled this way. It traveled to the east, got pushed under the North American plate, melted, and volcanoed up.
That's right.
Volcanoed. Is that a word? It is now.
It is now. Okay. Hawaii is the same thing. Ooh, there's a cool picture.
Oh, that's awesome.
So there are a couple of different kinds of volcano. Well, there's different kinds of volcanic eruptions. There's this kind, like in Hawaii, which you have this flow of hot, very hot, melted rock. And you can see it's shooting out from the top. It depends on the type of rock it is. And it depends how much gas there is coming up from under the ground. Here, there's not a lot of gas, so you just have the melted rock coming out. Mount St. Helens was a different story. As a matter of fact, next week is the 40th anniversary of the eruption of Mount St. Helens. And I think we might have a picture of that.
I hear it's going to be a blast.
That's not it. That's it.
There we go.
So this is what happened in Mount St. Helens, and it's not lava coming out. There's a lot of dust and ash because there's a lot of gases trapped in the underneath the rock that was melting, and so it came up as ash, and we saw some ash here, and we're what, 50, 100 miles from Mount St. Helens?
Yeah,
100 miles, and it went all across the continent. It went up miles, and then the wind would blow, and
you can kind of see that happening in this picture. There it goes up, 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 and then you can see the wind catches it.
Yeah, and moves it around.
Yeah.
So this is an example of an eruption that was more dust and gases.
Yeah.
Let's go back to the one we missed.
There we go.
One. So here's the one we were talking about, where the plates are separating and new rocks are coming in to form this mid-Atlantic ridge, for example, or these underground range of volcanoes. So it's not just one mountain underneath the water.
A whole line of them.
It's a whole line of them, like the Rocky Mountains underneath. And so that's how that happened. I thought that was pretty interesting.
Yeah. Now, one of our viewers said that they lived super close to Mount Hood, and they were a little bit nervous about it. The nice thing about volcanoes is they don't just erupt out of nowhere and surprise you.
Right.
There's always signs for quite a while beforehand. They knew when Mount St. Helens did this, they knew that something was coming. They knew weeks in advance that something was going to happen. They couldn't predict exactly this.
Right.
But they knew it was starting to grumble. It was starting to wake up.
And they asked anybody living in that area to move out of the way.
Yep.
And it's not so much people on the west side, because again, most of the time the breeze is coming from the Pacific Ocean and going east. So if you're on the west side, I wouldn't be too close, but that's better than being on the east side, because that's where all of that ash and wind and gases are coming out. And they knocked this, you might be able to see it here on the picture. Thousands of trees were knocked down, and they looked like matchsticks just lying on the ground from the blast.
Yep.
That's a pretty big blast to knock down a tree.
Nature is not just a tree, an entire forest.
Right.
Yeah. And Lauren's asking, what are the signs? Well, you should become a geologist. I love the questions that you're asking. There's earthquakes happening that are different than normal. They can hear and feel the magma, the liquid rock moving around under there. And there's more of that happening than normal. They can hear gases kind of moving around. Like when you have an upset stomach and your stomach is rumbling, you're like, uh-oh. all right, I'm not feeling too good. I know it's coming.
Right. And sometimes they see these little mini eruptions before the big one, or they have this coming out from the side of the mountain. They have some gas coming out and venting coming out. So there's ways of that volcanoes let us know it's time. Okay, we're going to talk about the tallest mountain in the world, mountains in the world, the Himalaya. Himalayas are a mountain range between India and Eurasia, and so they have come about because the two plates are moving towards each other and they're pushing up some of the land. As a matter of fact, the Himalayas are about 5.5 miles above sea level.
That's a lot.
5.5 miles. If you've ever walked 5.5 miles, think of doing that straight up. That's how tall these mountains are. And not only that, this began, this making of the mountain by the two plates coming together started about 50 million years ago. And every year, the Himalayas get higher by 3 to 6 inches due to these collisions, due to these plates moving together. 3 to 5 inches, you figured 3 to 5 inches times 50 million years, that's going to be quite a bit. Well, we don't have time for that.
Oh.
We don't have enough fingers for that either. So not all collisions form mountains. Sometimes you have a collision and you have them slowly rubbing up against each other, but going in opposite ways. So if you have one going this way and one going that way, they can rub, well, there you go. But the two plates are going in opposite directions, but there's a lot of friction, a lot of things slowing it down so it doesn't move. So the pressure builds up and up and up until it slides. And that slide is called an earthquake. And you've probably heard about earthquakes and seen earthquakes. I lived in San Francisco. I was there for the big one in 1986, 9, 2, 6,
89.
89. Okay.
I think it was 89.
Whenever. In the 1980s. In the 1980s, there was this big earthquake in San Francisco, and it was caused by this. It was caused by the two plates moving in different directions, and it built up and built up and built up, and finally it slipped. And when that happened, I have a couple of pictures here to show you what could happen. There is not a road I would like to drive on. So you had these two parts, and sometimes when they slip, they not only slip this way, but one sort of goes up a little higher on. That's what happened here. You have this road. It's not much of a road anymore, but you could see the results of this slippage. And this could happen in just a few seconds. It's such a powerful force. Now, I know some people who have animals, and they tell me that they can tell when there's an earthquake coming because some animals seem to be able to sense this. Not I, but I have a friend who has had a horse, and she said she always knew when there was an earthquake coming because the horse would start running around the corral like this. Or I've heard people talk about other animals that could somehow sense this. Scientists don't really have a way to sense it, to measure this, but if animals can somehow sense it, there must be something. There must be something happening in the physical universe that animals can pick up on that we don't know how to measure yet.
Yeah.
Anyway.
Maybe one of you will be the one to figure that out.
Wouldn't that be cool?
I would be honored if it was one of you.
Yes. We could call it we could name a machine the isosograph or something, and whomever. Anyway, let's take a look at our next picture. This, there's another one. Earlier, maybe? No. Okay. Well, one more earlier? No. Okay.
No. Okay.
All right. Well, it was what happened in the Marina district in San Francisco. We had these houses. We'll probably come across it in a little bit. These houses, and all of a sudden they're jiggling around, and they broke up. And there it is. Not it. Maybe
I'll find it.
Maybe I didn't include it.
Just a second.
Okay. Anyway, so
go
that's one of the things that could happen when you have this slippage, and you have and that can form the earthquake, cause an earthquake. Now, what do you do if there's an earthquake? So there are some rules. You don't run into a building. Why? Because the building could collapse. If you're outside, stay outside. If you can quickly move outside and get away from the building, do that. If you're inside the building, but it's not safe to go out, then get away from windows. Why? Why should you get away from windows?
Well, because, and I'm going to pull here.
That's the picture.
Here we go. Yep, I'm going to pull this up, and I'm going to show.
That's the picture.
There we go. I'm looking at these windows. A lot of these windows are broken.
Yeah.
That window's still there, but a bunch of these windows are broken. That would mean glass is flying all over the place.
Exactly. I mean, if you have a window like this, you can see in some of the pictures, the window is now like this. And when that happens, that glass is going to break, and you don't want broken glass on your body. That's right.
Now, I saw someone say, stop, drop, and roll. That's what to do if you're on fire. For an earthquake,
yes,
those first two steps are actually the same. Stop. Don't go running anywhere. Just stop where you are, drop to the ground, and then get under something and hold on. Get under a table. This would be a good table.
Right.
Or under a chair, something to protect your head and neck especially, but the rest of your body too if you can. And then you hold on to it because everything's going to be shaking around, and you don't want to get under a table and the table just kind of walks away from you.
Right. Now, when I say go outside, I mean, if you're right in the doorway, go outside. If you're in your living room, don't go outside. Get under something that can protect you, because it could happen so fast you could never get out. Sometimes you can't get out the door. If you're in bed, put the pillow over your head and do that. If you're driving in the car, hopefully your mom and dad will pull over and put on the parking brake, and then the car, if you're away from buildings, the car will protect you from falling stuff.
That's right. There's one other thing I wanted to talk about. Now, we just figured out next week I'm going to be doing 3 or 4 classes on how to handle certain emergencies, what to do in an earthquake, what to do in a big storm, or if there's a wildfire or a tornado or something like that. So we're going to cover this much more in detail then. But usually when we start talking about earthquakes, someone's going to say, get in a doorway. It's much better under a table or a desk or something big and heavy that can protect you from falling stuff than a doorway. That came about. There was one picture of the aftermath of an earthquake in New Mexico or something like that, where all that was left was one door. The rest of the house was gone, and there was one doorway. That was one instance where that happened. That was one construction of house. And the way that house was constructed in that picture is not usually how houses are built throughout the United States. So that myth started happening because of one picture. But if something happens right now and I'm in this room, I am 100% getting under this desk. I am not going to get in the doorway.
Under the desk.
The doorway is not going to protect me from falling stuff as well as a desk will.
That's what they used to teach, but that they found that that is not true. So they stopped telling you to do that.
Yeah.
Now, sometimes these tectonic plates can slip while they're underwater. Remember?
Yeah.
So sometimes you have these plates and they meet underwater and they can slip underwater. And when that happens, just like it did with my hand, one of them will rise up like that. And so let's turn to that slide. Oh, no, not that one. Not that one. Maybe.
Sorry, everyone.
Maybe I don't have. Oh, yeah, that'll show it.
Yeah, there we go.
Yeah, so here you can see.
Sarah's got it.
Yay! On the left, there's this earthquake, and one of the plates goes up like that. When it does, it pushes up this huge amount of water, and these are underwater earthquakes, of course. Or actually, they're in the ground under the water, and they can lift up a whole big bunch of water, and that water will come and move through the ocean at about 600 miles an hour. And what happens is it doesn't seem to rise much when you're just looking at it,
It's just a
But-
little wave there.
Yeah,
Yeah.
but then when it gets to shore, all of a sudden it is a tremendous wave, or it can keep going and going and going for quite some time. And we have a couple of pictures. There's one. This is the picture of the tsunami. So when these earthquakes happen underwater, it could create a tsunami. Now, if it's just one that goes like this and one of them goes, in different directions, that doesn't make a tsunami so much. It has to be one of these where one of them pushes up some water and one of them goes down. And so this is a picture from the tsunami that happened in Japan a few years ago. And you can see it's just rolling right in over the land. And then we have another picture here of this happened after a tsunami. Now, somebody probably didn't park his boat there.
I was wondering where I parked it.
Did you see the boat in my driveway? No. So this is, the boat got carried in along with this water.
The water
and
came
then
up.
the water went down and the boat stayed there.
Yep.
And so this is what could happen in a tsunami. And there are sort of some telltale signs about whether a tsunami is coming that scientists have been able to figure out. First, the ground could be shaking. Right. So if you feel the ground shaking, that means there was an earthquake. So it could be a tsunami if you're living near the coast. Now, if you're living thousands of miles away from the coast, you never have to worry about tsunamis. You got earthquakes, you got these other things that we do have earthquakes in the middle of the country sometimes.
Mm-hmm. Yep.
But you don't, tornadoes, sure. Other things, big storms, yeah, it's a different story. Tsunamis, not so much if you're in the middle. But if you're near the coast, and I've seen these when driving on the Oregon coast, I've seen these tsunami evacuation, they have sirens and this
They
sort
got
of
signs and they're like, hey, if you keep driving this way, just be aware you're entering the zone that if this is tsunami, the water might come up to this point.
Yeah. Now, don't forget, don't freak out if you're in one of these zones, because 99.99999% of the time, no problem. It's just that little bit of time when there is that type of earthquake that lifts up the water, and it depends which way it lifts it up. If it lifts it up this way and you're over here, okay, it's time to be concerned. But if it lifts it up this way and you're down there, probably not a big deal.
Yep. But like I said, most of the time it's not a problem. It's just once every 300 years or so, depending on where you are.
Right.
Yeah.
And so, another telltale sign that there's a tsunami coming is if you're near the beach and all of a sudden the water goes out and it's very shallow. What's happening is it's getting ready to form this great big tsunami coming in. So if you're at the beach and all of a sudden all the water comes out, or a lot of the water, it was like this deep before and now it's this deep, it's time to head for higher ground.
Mm-hmm.
I was reading a story about this girl, this young girl who was with her parents in Indonesia.
Yep. I love this story.
And she had learned in school, she was on vacation, it was summertime, and she had learned in school about the tsunami and, how to know that a tsunami is coming. And she was with her parents and lots of other people on the beach. And she saw all the water, a lot of water coming out. All of a sudden it was getting very shallow. And she told her parents, I learned in school that when that happens, that means a tsunami is coming. And so the parents got to higher ground, the girl got to higher ground. They told everyone in the beach, get out of here, we go to higher ground, there's a tsunami coming. So you don't want to be, hugging a tree and sitting there and watching a tsunami come because we're not sure the tree will stay there.
Right. It probably won't.
Probably won't.
Yeah.
And if so, you don't breathe very well under, a whole bunch of water. So if you see something like that where it's all of a sudden getting very shallow, it's time to head to higher ground.
That's right. That girl saved a lot of lives because she was paying attention in school.
That's right.
And not just paying attention, but taking the information and thinking to herself, how could I use this?
And that's what
And
she
she
did.
did.
Another thing is if you see, you look out on the ocean, maybe you're at the beach, and you see this big wall of water coming, it's not the time to say, I wonder if that's a tsunami. It's time to head to higher ground.
Yeah.
Sometimes there's a loud roaring, sounds like a jet plane. And that roaring is caused by the water, stirring up. And so if you experience any of these things or hear of any of these things, it's time to head to higher ground. So we have a few minutes. James, do we have any questions?
Someone had asked if our school is close to the ocean. We are close to the ocean. We're about a 1 hour drive from the ocean. We would have to drive almost that entire hour to have any danger of any tsunami.
But I think the school itself is up on a hill that's hundreds and hundreds and hundreds of feet high.
That's right. We are currently, right now, 642 feet above sea level.
Currently?
At this exact moment, I checked it. Oh, currently. That's a water joke. Yeah, no, I checked very specifically. 642 feet right now, you and I, above sea level. Currently, at this very moment. So even if we were immediately on the Oregon coast, we would not need to worry about tsunamis at all. But most people on the coast don't need to worry anyway. As soon as you get, 20, 30, 40 feet up, depending on how high that tsunami goes.
Right.
Some tsunamis are only a few inches. After the Japanese tsunami in 2011, Oregon did receive a small tsunami from that same earthquake. It had to travel across the entire Pacific Ocean to hit us. And in most places, the tsunami was like an inch, so you didn't even notice. There was one place where it was a little bit higher. It was like a foot, and it damaged some boats. And so that was okay. But as soon as you get uphill enough distance, you're safe.
Right. Okay. Do we have any other questions?
Let's see. See, someone said that they are 12,000 feet above sea level. You're totally fine. Yep.
12,000 feet.
Yeah. So no tsunami is going to get you up there. I promise you that. Yeah.
Right.
Exactly. And no, you're right. That would not be a good time to wonder if you could surf that water.
You don't want to surf that water because what happens sometimes when you're surfing is you fall off the board. And if you're surfing the wave and you're doing great, and here's this building, you're surfing right into a building or a tree, you probably don't want to do that.
Nope. And knowing my level, my skill in surfing or lack of skill, I would be hitting every tree if I could even stay on the board.
Right.
Something I want to say about this is that when learning about any kind of natural disaster like this, we call it a disaster. Nature just calls it, Tuesday.
Yeah. So what's happening?
It's just how it is. It was always doing this, and then we came along and got mad at it.
And it's still doing
what it always does. If it scares you, if it makes you nervous, or if you're worried about it, that's okay. You're paying attention. It just means that you're not done learning about it yet.
Right.
You keep studying, you keep learning more about it until it doesn't scare you anymore. There will be enough that you can learn that you're like, I know what to do.
Right.
Earthquakes are scary, but you and I know exactly what we would do in an earthquake.
To be forewarned is forearmed.
There you go.
I only have 2 arms myself.
1, 2, 3, 4. 4 arms. Same with the tsunami. When I go to the ocean, I'm aware that a tsunami can happen. I'm also aware that there's a hill that I can get to in 5 minutes that's 100 feet tall, that no matter what happens, that water is not going to get me up there. So I'm just going to sit and enjoy my hot dog.
Right. And also you could be aware that it's very, 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 very rare. It's like if it happens so rarely, I mean, we're talking about Mount St. Helens, for instance, 40 years ago. Sometimes mountains can stay dormant for, for thousands of years.
Yep.
So you don't have to sit there and wonder, is it going to happen now? Oh, no, is it going to happen now? Because these things, we're talking about geologic time. And what geologic time means is a long, 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 long time. 100 years is nothing.
It's nothing.
We're
It's a
talking,
blink of an eye.
Right. So remember, we're talking about the Himalayas building up 50 million years it took for that to happen. So don't sweat it if you're by the beach, and don't be fearful because it happens so irregularly. Now, when it does happen, it's a big deal, but it's very infrequent that it happens. We're talking about hundreds of years. Now, there are some places that it's more likely to happen than others because it's right along the plates, right along where one plate meets the other. And so that's more likely to happen. But if you're not near the plates, or I wouldn't worry about it because there's not a lot you can do.
Yeah.
There's not a lot you can do. And it happens very infrequently.
That's right.
Okay.
And we are just about out of time here, so we're going to wrap it up. As I mentioned earlier, next week I'm going to be doing 3 or 4 classes talking about how to act in certain emergencies. What are the correct responses? So if this has worried you or just interested you, you're like, this is cool, I would like to learn more about it, join me next week. We'll definitely be learning more about it and how to respond to these various things. And then something I learned a few weeks ago is that the speed at which those the plates move is about the same speed that your fingernails grow.
Right.
Not exactly, but it's close enough.
Right.
So if you think like, well, if I didn't cut my fingernails and I know that in a few months it would be like that long, that's how much the plate that you're sitting on moved in that time.
Okay. So you're going to talk about, when you talk about emergencies, you're going to discuss hiccups?
Hiccups are the worst emergency I can possibly imagine.
I'm telling you, sometimes it seems that way.
When I get hiccups, it's bad. So we're going to talk about earthquakes, hiccups, all the worst ones.
How to cure hiccups. I have got a way of curing hiccups. I'll tell you so you can use it for your broadcast.
Yeah. Okay, good. All right.
So
tune in next week to find out.
Remember, curiosity is the cure for boredom. If you feel yourself bored, find out something you're interested in. Find out something you're curious about and you want to know more about. And until next time, stay curious, and we'll see you again on our next broadcast. Have a great day.